All right, so we're going to be taking a look now at learning goal number 27. That's using the distributive property in linear equations. So we're going back to linear equations and we're going to be taking a look at how do we solve them, but now we're going to add in a little bit of a wrinkle as to how to kind of go through brackets. And we're going to do a little bit of review as well. So first thing in review is a linear equation represents points that when they're graphed, form a straight line. We can also think it can also be a pattern where the values of x and y increase or decrease by a consistent value. Okay, they're going to increase or decrease by a consistent value. So again, remember that it can go up by a consistent amount or go down by a consistent amount, depending on the type of pattern that we have. Now, a linear function will have two variables, which are related to each other. Okay, so they're always related to each other. Now, the way that they're related is going to be based on the equation that they're a part of, but that is kind of part of the relationship. X, okay, we're usually going to use X. X is the independent variable and is always graphed on the horizontal axis. Y, on the other hand, is the dependent variable, okay, and is always graphed on the vertical axis. We've taken a look at graphing linear functions in the past. This part should be somewhat fresh in our minds. So we have two variables. We have x and we have y. X is going to be independent. That's going to be something that is just the way it is. Often we refer to it as time or something like that, where it keeps on going no matter what. And then the y value is going to be what is dependent on the x, and that's going to be in a relationship using our equation that we have. So let's go through how do we solve and how do we use our equations to solve for solving our for a variable. So let's use the equation y equals 2x plus 4. I'm just going to highlight that really quickly. We're going to use that now a couple times here. There we go, y equals 2x plus 4. We want to solve for y when x equals negative 4. So what we do with that one there, we have y, wrong one there. Let's redo this. Let's try this one again here. All right, here we go. And function, there we go. Y is equal to 2, and now we're going to insert the negative 4 in for x plus 4. So what we've done here is when x is negative 4, we're just going to insert it into the equation. Now the equation has an x spot. We plug in the negative 4 into that x spot. We don't change the equation around at all. We just plug it in. In here, it's saying 2 times x, so we do 2 times negative 4, and then we add 4 to it. Well, when we do this here, 2 times negative 4 is negative 8. And so this would then be, so we're going to kind of follow along with order of operations here. This would be negative 8, plus 4. And when we complete that, it's going to be y is equal to negative 8 plus 4, which is negative 4. So when x is negative 4, y is also negative 4 in this scenario. Now that doesn't necessarily always work, but in this case here, it worked out really nice. Now let's also solve for x when y equals 2. So what we're going to do is we're going to plug the 2 in for y. So we're going to replace the y value right here. Okay, that y value we're going to replace with 2, and then we're going to keep everything else the same. Now let's see here. When x was negative 4, y was negative 4. So let's see if when y is 2, is x also 2? Well, probably not. But we can at least go through that and see. All right, so this is what we're going to have here. We have 2 is equal to 2x plus 4. Now, to find out what x is, we can't just solve like we did for y. We actually need to isolate x and get it all by itself. Here, y is already isolated. It's all by itself. here we need to isolate the x. So what we're going to do is we're going to start off by getting rid of this 4, and we're going to subtract 4 from both sides. And so we need to subtract 4 from both sides of our equation. So what that's going to do then, it's right here, 2 minus 4 is negative 2. And then 4 minus 4 is 0, so it's just 2x plus 0. So we don't have to put that in at all. We can just leave it exactly the way it is here. Negative 2 is equal to 2x. Next step, let's use the same colors here. We want to get rid of the 2. Well, there's a 2 in front of the x. It's multiplying. The opposite operation is to divide by 2. So we're going to divide both sides by 2. Now that's a positive 2. And sorry, this cancels out here. This is now, the 2's are going to cancel out. They're going to become 1. Okay, not 0. They're going to become 1. And negative 2 divided by 2 is negative 1 is equal to x. Tells us that when y is 2, x has to be negative 1. That's the relationship. Those two numbers are related based on the equation. Okay, when x was negative 4, y was negative 4. When y is 2, x is negative 1. Now, an equation can also have operations on both sides of the equal sign. Okay, so something like this one here. Okay, we have y minus 3 is equal to x plus 5. Okay, so there's going to be a relationship here, but now we also have operations on both sides. Neither one of our variables is isolated at this point. So what we need to do to start with here, okay, sorry, just as a regular linear equation, we need to isolate the variable that needs to be found. Okay, and that could be either x or y. Depending on if we need to find x or y, we're going to isolate that one. So the first one here, we're going to solve this equation when y is equal to negative 7. For a given y, we're going to have to isolate x. And we can do that by plugging our y value that we know. Oh, here we go. Let's just highlight that there. We know this one here. We know that y is equal to negative 7. And so we are then going to isolate the x to find out what it is. What's the x that's related to negative 7? Now to do that, we plug the negative 7 in for y. So we're going to have negative 7 minus 3 is equal to x plus 5. In this case here, oh, that's not an equal sign. That is, there we go. There's an equal sign. Maybe it was. So what we need to do here is we want to get x all by itself. We need to move this 5 over. What we're going to do first, though, is anytime we can combine numbers together, we want to do that. And so in this case here, we can combine these two numbers. And I'm just going to use a pen here to do that. Okay, these two right here can be combined. It's just negative 7 minus 3. Negative 7 minus 3 is negative 10. That's all it is. So this is negative 10 is equal to x plus 5. All right, so what we've done is we've actually simplified already. We've tried to kind of group any terms that we can together. Here we couldn't group them yet because it's just y, but once we know what y is, we can then group them together. And we would do the same thing as if we knew what x was, we would group whatever x was with positive 5. Next step, now we want to get x all by itself. Again, that isolating part. We have this positive 5 here, so we need to subtract 5 from both sides. There we go. So we subtract 5 from both sides. And what we're going to get then, let's get our function keys up here. Negative 10 minus 5, negative 15 is equal to, well, now we got x all by itself. So we know that when y is negative 7, x has to be negative 15. That's going to be our pair that we have. And we could end up graphing that pair, okay, just like we have in the past on a grid, or coordinate grid, where our y would be negative 7 and our x would be negative 15. Those are our pair. Okay? But we had to isolate our value first when we did that. I'd like you to work on questions 1 through 4. It's about isolating the variables. Sometimes the variables are very isolated. Sometimes we need to go through and isolate it as well.